Part 3, rules of logarithms. As we go through this section, we're going to look at these 3 rules, and then we're going to focus on the change of base formula. So we have the product rule, which means if you're taking the log of 2 things being multiplied, so in this case we have m times n, all right, so right here this is m times n. So if you have 2 things being multiplied, you can separate the logs. They're still going to have the same base, okay, but we're going to use addition. So you can separate them into 2 logs using addition. The power rule says that if you have log of something raised to a power, you can take that power and drop it out in front. So that's what's going on here. So now it's r times the log base b of m. The quotient rule is similar to the product rule. If you're dividing 2 things, so m divided by n, instead of addition for the product rule, we're going to separate them into 2 logs, and we're going to have subtraction between them. And then the change of base formula says that if we have this odd base, base b, which we know we can't type into the calculator, we can only type in log base 10 and log base e in the calculator, we can convert that using the change of base formula to log base 10 or log base e so that we can type it into the calculator. Go through these examples, we're going to be referring back to those rules, so have them handy. Example 1, given that log of x is equal to 2, log of y is equal to 3, and that log of 2 is approximately 0.3, and log of 3 is approximately 0.48, evaluate log of 2 times x cubed times y. Now, what we're looking at here is we have to take and break this apart. We only know the values of log of x, log of y, log of 2, and log of 3. So we need to break this apart, okay, in order to get down to just those values. So if you notice, we have log, and I said it, of 2 times x cubed times y. And we know that the product rule says if you have things being multiplied together, you can separate them with addition between them. So I'm going to rewrite this as log. The base stays the same, so it's base 10. I don't have to write that. So I'm going to change it to log of 2 plus log of x cubed plus log of y. So I use the product rule. These 3 things are being multiplied, so I can separate them into separate logs with addition between them. Now, if you look up top, I know the value of log of 2. I also know the value of log of y. But in between, we have log of x cubed. So here, I don't have a log of x cubed up there. I have a log of x, but I don't have a log of x cubed. So we have to use the power rule. Okay, so I'm going to go back up here. We use the product rule first to separate them. Now we're going to use the power rule on this middle term here. So I'm going to rewrite what remains the same, log of 2 plus, and then the log of y over here. Now, in the middle, the power rule says if I have an exponent, I can take that exponent and pull it out in front. So now I'm going to have 3 times log of x. Okay, so now let's look at what we have. What is log of 2 equal to? Well, up there it tells us that log of 2 is equal to 0.3 plus 3 times log of x. Log of x is equal to 2 plus log of y. Log of y is equal to 3. So I have 0.3 plus 6 plus 3. So my final answer is 9.3. Now I want you to notice they gave us kind of a decoy item. They gave us the value of log of 3. Notice we didn't even use that, okay? And that's okay. So my final answer is simply 9.3. Example 2, part A. we are going to write the natural log of x times x minus 4 in expanded form. So we're going to use those rules, the quotient rule, product rule, and power rule to expand this, okay? So if you look at this, natural log is the log that I'm using, log base e. And then in here you see I have x times x minus 4. So I know that I'm going to be using the product rule, okay, because I have multiplication. The product rule says if I have two things being multiplied, the first thing is this x, the second thing is the x minus 4, that I can separate it into two separate logs. So I'm going to write it as the natural log of x, and I know product rule tells me I'm going to put addition between them, plus the natural log of x minus 4. Okay, now I look at natural log of x and I say, okay, do any other rules apply? Well, no. I look at natural log of x minus 4. Do any other rules apply? Well, I have subtraction between these two. The only rules we have are if there's multiplication or division between the two. So since we have subtraction, we can't go any further. So my answer is natural log of x plus the natural log of x minus 4. Example 2b. We're going to expand log of 2x plus 3 divided by x plus 4 squared times the square root of x minus 5. Now, I'm going to first just take this 2x plus 3 and put it in parentheses. That's all stuck together. So we can see right here that we definitely have some division going on, okay? So anything that's in the denominator, we are dividing by, all right? So those are going to have to be subtracted. So let's go ahead and start expanding this. This is going to be log of 2x plus 3. And then I'm dividing by x plus 4 squared, so that's going to be a minus log of x plus 4 squared. Again, I'm dividing by, so minus again, the square root of, oh, let me erase, I forgot the log. Minus log of the square root of x minus 5. Okay, so what I did is I took that division and I separated it. Now, you might wonder why there's a minus in front of the square root of x minus 5. And again, it's because we are physically dividing by that value. Yes, I know it looks like we're multiplying x plus 4 squared and square root of x minus 5. We are, but in the grand scheme of things, they're both being divided. So now we see if we can break it down a little bit further. Well, 2x plus 3. Remember, addition can't be broken down, so that remains the same. Log of 2x plus 3. Minus, here we have x plus 4. We know that addition can't be broken down, but we have this power. So this power can be brought out in front. So I'm going to write that as minus 2 times log of x plus 4. Minus, now this one's a little tricky. We have log of square root of x minus 5. I'm going to rewrite it as the log of x minus 5 to a power. Remember that square root is really the 1/2 power. So I actually can do a little bit more work on that last piece. So let me rewrite everything. Log of 2x plus 3 minus 2 times log of x plus 4 minus, now I have the power rule again. I can put that 1/2 out in front, times log of x minus 5. All right, so I can't use the power rule anymore. I can't use the product rule, and I can't use the quotient rule, so I'm done, and this is my final answer. Example 3. This time we're going to write 3 times the natural log of x minus 1/4 natural log of x squared plus 6 in condensed form. So in the previous examples we were expanding. Now we're going to go in the opposite direction. So if you think back and you look at what we did previously, the last step when you were expanding was to take the power, use the power rule and drop the powers down. So that's actually going to be our first step when we go in the opposite direction. So right now I have this 3 out in front and I have a 1/4 out in front. So those are going to become my powers. So I'm going to rewrite it as natural log of x cubed minus natural log of x squared plus 6 to the 1/4 power. Then I'm going to take, and I don't like that 1/4 power, so I'm going to rewrite that as a root. So I'm going to write it as natural log of x cubed minus natural log of the 4th root of x squared plus 6. All right, and we know that they're equivalent. Now that I've done the power rule, now I can take things and combine them back together using either the product or the quotient rule. Well, since I have subtraction between these two, I know it's going to be a quotient rule. So I have right now 2 separate natural logs. The quotient rule allows me to combine it to one natural log, and since there's minus, I know there's going to be division. So it's going to be the natural log of x cubed divided by the 4th root of x squared plus 6. All right, that is as condensed as we can get. Example 4, we're going to find the exact value of 10 raised to the 4 log base 2 minus log base 2 power. So the first thing I'm going to do is I know I have 10 raised to some power. So I'm going to look at that power separately. So I'm going to rewrite that as 4 log of 2 minus log of 2. So let's just work with the power. Let's go ahead and simplify what we can, and then we'll come back to 10 raised to that power. Now notice, we have subtraction between here. We just learned how to condense things. All right, so we know we're going to have to condense this. The first step in condensing is to remember to put your power back. When you have a number out in front, that is using the power rule. So I'm going to have log of 2 to the 4th now minus log of 2. All right. Now that I have my power back up, I have the minus between these two logs that have the same base. So I'm going to go ahead and combine those using division. So that's going to become log of 2 to the 4th divided by 2. Well, I know that that can reduce. 2 to the 4th divided by 2 is 2 to the 3rd, which is simply log of 8. All right, so now I'm going to take that. I know that this is my power. I just simplified the exponent. It was 10 raised to this power. So I'm going to go over here and write it now as 10 raised to the log of 8. Now I know that since there's no base written here, it's automatically a 10 when it's not written. So I have 10 raised to the log base 10. Since they have the same bases, they are inverses of each other. They're going to undo each other, and my answer is just 8. Example 5, use the change of base formula and a calculator to evaluate each of the following to 4 decimal places. So now when we look at these, you see that we have in the first one log base 1/5 of 4. Well, log base 1/5 cannot be put in the calculator. So we're going to use change of base formula. There's 2 ways it can be written. Okay, we're going to change it to either base 10 or base E, which are 2 things we can type into the calculator. So base 10, remember, is just a log by itself. So the way the change of base formula works is you're going to take log of 4 divided by log of 1/5. And how you know where the numbers go is the base always goes on the bottom. You could also choose, instead of using log, to use natural log. So you could say natural log of 4 divided by natural log 1/5. Either way is correct, and then you're going to go ahead and type either one of these in your calculator, or you can type both in to verify that you're going to get the same answer. So what do we get when we type it in the calculator? Negative 0.8614. Now take a minute and type it in your calculator and make sure you're getting that. If you're not getting that, make sure you ask a question about how to get that in your calculator when we have class. The next one, log base 8 of 3. Remember, the base goes on the bottom, so we could either write it as log of 3 divided by log of 8, or natural log of 3 divided by natural log of 8. Either way, when you type it in your calculator, you're going to get 0.5283. 6. Find the inverse function for f of x equals log base 13 of x plus 5. So now, I'm going to go ahead and write my function down here, but instead of using f of x, I'm going to use y. So my function is y equals log base 13 of x plus 5. So let me refresh your memory on how to find an inverse. Steps are, first you're going to switch x and y, and the second step is you're going to solve for y. Okay, so we've done inverse before. We're now just doing it for a new type of function, which is the log function. So let's switch x and y. That's going to give me x equals log base 13 of y plus 5. Now there's two ways you can look at this, okay? I like to have my log written on the left-hand side, so I'm just going to rewrite this as log base 13 of y plus 5 equals x. So I just flip-flop the sides they were on. Now, what I do is my loop. Okay, so that tells me that 13 to the x is equal to y plus 5. Now I can go ahead and solve for y by subtracting 5 from both sides. That's going to give me 13 to the x minus 5 is equal to y. And that is my inverse function. Y equals 13 to the x minus 5. Now I want to show you another way, okay, that works equally the same. So log base 13 of y plus 5 is equal to x. I know that if I have log base 13, if I have 13 raised to that power, they're going to undo each other. So I'm going to take and I'm going to have 13 raised to each side. They undo each other. So on the left-hand side, I have y plus 5. On the right-hand side, I have 13 to the x. Same thing, I'm going to subtract 5 from both sides, and I'm left with y equals 13 to the x minus 5. So no matter which way you think about it, you're going to get the same answer. For example 7, we're going to find the inverse of g of x equals natural log of x minus 17. So again, I'm going to take the g of x out. I'm going to write it as y. And I'm also not going to write natural log. I'm going to write it as log base e. So I'm going to write it as y equals log base e of x minus 17. Now remember that natural log is the same as log base e. It doesn't matter how you write it, okay? I'm just pointing that out for you. So my first step is to switch x and y. So x equals log base e of y minus 17. So now my goal is to solve for y. So the first thing I'm going to do is I'm going to add 17 to both sides. So I'm going to have x plus 17 is equal to log base e of y. Now again, I like to have my log on the left-hand side, so I'm going to write it as log base e of y is equal to x plus 17. So when I look at that, I go, okay, how can I rewrite this? Well, now I'm going to do my loop. I'm going to do e raised to this power is equal to y. So e to the x plus 17 is equal to y. So I've solved for y, which means this is my inverse. Now again, we're going to look at it two ways so that you have some options. So I'm going to actually keep it the same this time. I'm going to go y equals natural log of x minus 17. We know step 1 is to switch x and y. So x equals natural log of y minus 17. First step, just like the other one, was to add 17 to both sides. So I have x plus 17 is equal to the natural log of y. Well, we know that the inverse of natural log is base e. So we're going to take and we're going to do e raised to the natural log of y and e raised to the x plus 17. That's going to give me e to the x plus 17 on the left-hand side equals, we know e and natural log are inverses, so they undo each other, equals y. Again, either way, you're going to get the same answer.